Good afternoon to all and honorable authorities of the 29th International Materials Research Congress. It is a pleasure for me to present my work, Synthesis and Characterization of Polymer and Oligomer from Benzyl Alcohol and Halides. This work was carried out at the Chemistry Institute of National Autonomous University of Mexico by Dr. Rosa Estela Lazo under the direction of Professor Salmon. The synthesis of polymer and oligomer from substitute benzyl alcohol and halides, the derivatives were synthesized in the presence of the trifluoromethasulfonic acid as a catalyst by the polymerization reaction. In 1993, Hiri et al. Report this synthesis in the presence of the concentrated mineral acids as a catalyst that induces a benzyl cation over the aromatic ring. You can see it in the figure 1. It is important to mention that since 1995 that 2011, Salmon M. Cruz Almanzan, among others, have reported that the trifluoromethasulfonic activity and the clay acid, which induce the aromatic substitution that involve for the formation of the benzyl carbocation in the synthesis of oligomers from benzyl alcohol and derivatives. You can see in this slide the formation of the dimer from the paramethoxybenzylic acetate plus paramethoxybenzyl. The next, in this slide, the methodology in this work, the synthesis of the polycondensation reaction were performed in the presence of the superacid as a catalysis at a different temperature. You can see it in the figure 3, it shows the polymer in form of resin. It was obtained at 120 degrees and some oligomers were obtained at 70 degrees respectively. In this slide, you can see different monomers that we use in the synthesis of polymerization condensation reaction, and we obtain oligomers and polymers. For example, a polymer was prepared by the condensation reaction in a relation to 1 moles of 4-hydroxybenzyl alcohol with the 1,4-benzeno-dimethanol using 0.1 and 0.5 of the trifluoromethasulfonic acid as a catalyst. You can see the figure 5. The synthesis of benzyl alcohol proceeded with high selectivity and is sensitive in the number of the alkyl of methoxy substituent on the aromatic ring. In this case, we obtain oligomers and polymers in the DMSO solvents. The next. Results. The synthesis of oligomers, polymers, and its comparative analysis is reported. The synthesis results in the desirable polymer. You can see it in the figure 6. The polymer first was precipitated, then washed, then filtered, and finally dried it. The structure and composition, the polymers, oligomers, and the fields were obtained from some benzyl alcohol derivatives are showed in the figure 7. They were analyzed by X-ray diffraction, infrared, and MR, and TGA, DCS, and AFM. In this slide, you can see the infrared spectrum polymer. The infrared spectrum polymer show the characteristics bands of alcohols in the left region. It's absorbent strongly in the 3650 and 3350 centimeters regions, and you can see the stretch of methylene near to the 2918 and 2840 centimeters. Also, you can see the stretching of aromatics and aryl alkyl other displays as asymmetric COC stretching band and 1,300 to 1,200 centimeters, among others. The next you can see by thermogravimetric analysis the thermal behavior of the polymer was studied with the TGA technical figure 9 thermogravimetric analysis were carried out under the nitrogen and heating rate at 10 degrees. These results which were determined from the original thermograms. In general, the materials exhibit good thermal stability without significant weight loss of the range of temperature. By atomic forces microscopy, you can see in the figure 10 fields showed a very homogeneous surface. By X-ray diffraction, the oligomers were obtained in the dust-like form, and they showed an amorphous structure from X-ray diffraction, and analyzes polymer were showed an amorphous structure mainly. Finally, the conclusions are a novel aromatic polymer was obtained from a condensation reaction of 1,4-benzeno-dimethanol of 4-hydroxybenzyl alcohol catalyzed with trifluoromethasulfonic acid. This polymer is insoluble in organic solvents. However, oligomers are soluble in several solvents such as ethyl acetate, acetone, tetrahydrofuran, and the molecular weights and the oligomer were low. The oligomer were synthesized at low temperature, 70 degrees. The structure and composition on the polymer obtained at 120 degrees were analyzed by X-ray diffraction, infrared, and NMR. Finally, the AFM results for polymer fields showed a very homogeneous surface and the low roughness. In general, from analysis of the TGA and the DSC results, the aromatic polymer exhibit a good thermal stability. Finally, the XRD results indicate that the aromatic oligomers are totally amorphous. You can see some reference if you need to review. Thanks for your attention in International Materials Research Congress.